Hello and welcome to a new episode of Library of the Week. Today we will be talking about Matplotlib, which is a Python library used for data visualization. This is part of a Medium series I do about Python libraries and I try to publish them weekly. You can find the link to the article in the description of this video. There are a few reasons why you should get familiar with Matplotlib. The main one would be that this library is a really old project and it is used by many other data visualization libraries and even by other libraries that are not specific for data visualization, such as pandas or networkx. There are many others. So whether you like it or not, you will sooner or later be confronted to Matplotlib. Another good reason to use Matplotlib is that it gives a lot of customization possibilities to create really nice charts. And last but not least, it is a very old project with a big community, and this means that there is extensive documentation. So even if the syntax is a bit complex, you will almost always end up finding a solution, even if it involves a lot of Googling or nowadays a lot of ChatGPTing. So Matplotlib is probably the oldest Python library for data visualization. It is a very reliable choice if you want to create any kind of chart, from 2D charts to even 3D charts. I will show some examples later. Matplotlib follows an imperative approach and it really has a very complex structure. So Matplotlib has three different layers. A backend layer, which is really the behind the scenes layer. This really is all the objects that create all the elements of your chart, and as a analyst or data scientist, as an user basically of Matplotlib, you will very rarely interact with. This is for developers. Then you have the artist layer, and artists are classes, as in Python classes, that build blocks of the plot. The most important classes are figures and axes, but you have others and you can create full charts using this artist layer. It provides a lot of personalization, but the syntax of the artist layer is really complicated and most users wouldn't feel comfortable with it. So this is why Matplotlib also comes with a pyplot layer, which is more user friendly. The syntax of pyplot is similar to MATLAB. When they created Matplotlib, MATLAB was very popular. Well, I think it still is in research environments. So one of the reasons for creating Matplotlib was that the lab where John Hunter, which is the creator of Matplotlib, was working didn't have sufficient licenses to create their visualizations. They were familiar with MATLAB and they created a Python library for data visualization that had a similar syntax. So all that comes from that time. Let's now see some basic statistics about Matplotlib. These statistics are from July the 25th of 2023. We are currently on version 3.7.2. In the last 30 days, there was over 30 million pip downloads and almost 20 million conda downloads. The first release of this library is January of 2006, so you see it's pretty old. And the latest release is from July of 2023. It doesn't have any dependency. In fact, this is a library that is used by many other libraries, and in GitHub this project has over 17,000 stars, almost 7,000 forks, 586 watchers, more than 1,000 contributors, and it has a source rank of 28 in libraries.io. So let's now talk about the people behind this project. Matplotlib was initially written by John D. Hunter, and the project has over 1,000 contributors. Matplotlib is a NumFocus sponsored project, and it is worth mentioning that John Hunter himself was one of the founders of the NumFocus organization. The project is under BSD license, so it's totally open source and free. And since this is such a huge project, a huge library, it's governance is very well structured. The documentation, which by the way is very complete and very nice to check if you want to learn more about Matplotlib, there is actually very good tutorials, but the documentation holds a document where you can learn all about the governance of this project, how many resources companies who want to be in the council need to allocate to the project to be in those committees, and so on. As I also said earlier, this is a project with a huge community, and you have over 70,000 posts on Stack Overflow, so you will very likely find answers to whatever question you have. So let's now talk a little bit about the pros, the cons, and the alternatives to Matplotlib. In the pro side, I would say that since this library is really used by a lot of other libraries for data visualization, it integrates very well with almost any project. Almost all Python data structures are easy to use with Matplotlib. You will hardly have those kinds of problems. And another great thing about Matplotlib is that it offers a lot of customization possibilities for your charts, and that is always nice to have. On the negative side, since you can customize your charts a lot, this also means that there is a lot of complexity. It is not an easy library to learn. The syntax is also a bit outdated. MATLAB is not very popular nowadays, and you really have libraries out there with a syntax that is more user-friendly. Even the pyplot layer, which is supposed to be the easy user-friendly layer interface, is not as easy to use as other libraries. The Python ecosystem offers lots and lots of libraries for data visualization, so there is really a lot of alternatives. I would like to mention Altair. I think it's pronounced Altair or Altair. Altair is built on top of Vega. As you can see, you can do a lot of very cool visualizations with it, and it follows a declarative approach, so the syntax is easier. Plotly is another very popular library out there. It really has a lot of nice visualizations, but in this case it lays over JavaScript, and it's more suited for interactive visualizations. Also, the syntax is not very difficult, and it has a lot of documentation. And I would also like to mention Seaborn. So Seaborn is actually built on top of Matplotlib. This is one of them. It is a library specifically designed for statistical data visualization. It is very nice and you should check it out. So now we are going to see a few examples on how to use Matplotlib. We will start with the easy one. We import pyplot from Matplotlib. And now we are going to create a pandas data frame just so we have data to plot it. I'm not going to be explaining all of this in detail, and all the code is in the Medium article that is in the link in the description. So we import pandas, and we also import sklearn to get the iris dataset. So we create a df iris dataset with all the data for the sepal and petal length and width for different species of plants, and this is how our data frame looks. For our quick example, we will also create a second data frame, so don't worry too much if you are not familiar with this syntax. I invite you to learn how to use pandas. It's always good if you want to work with data, but we are going to aggregate the data from the iris dataset, and we are going to create a data frame with the mean for the sepal length of each species. So you see we have 3 species in the data frame: Setosa, Versicolor, and Virginica. The class that you see here is just a numeric identifier for each one of them. So it's categorical, it's a categorical value. And the third column is the mean for the sepal length for each species. And now we can create a chart to represent this data frame. To create a bar chart, we use plt.bar. It needs two mandatory arguments. It can have more, we will see that a bit later, but we basically need the x-axis, which will be the species, so df average sepal length, the data frame we just created. The value for the species will be in the bottom of our chart, and the value for the y-axis, or in bar charts this is also referred to as height, which will be the sepal length. We use plt.x label and y label to label the axis, and plt.title to create the title. Let's see how this looks. So you see species and average sepal length are our labels. The title is here. And as you can see in the x-axis in the bottom, we have the species. The data is broken by species. And the y-axis, or the height, is the value, the average value for sepal length. 5, 5.9, and 6. So we have here for setosites 5, 5.9 for versicolor, and 6.5 for virginica. Now let's create some more complex plots. The code you see here creates the same plot as above, but with different colors. As you can see, colors here is defined as plt, so this is pyplot.cm, which stands for color map, .set2. Set2 is a color map or a color palette. I like to call them color palettes. You can find in the Matplotlib documentation all the information about the different color maps that you can use, and you can see here set2. There is 8 different colors. So this colors variable is a NumPy array with the RGBA values for the colors in position 0, 3 and 6 of the set2 color map. So if we come back to our color palette, set2 in position 0 is this green color, in position 3 we have this pink color, and in position 6 we have this brown color. And as you can see in our final chart, this is the color that we have. So we create our bars object using ax.bar like we did before. We just add this extra color equal colors argument. We still give labels to the x and y axis, and we set a title. We rotate the labels using the tick params function. So this is just to make these labels in the bottom a bit fancier. As you can see, they're rotated by 45 degrees. And then we find this code here, which looks pretty intimidating. What we are doing here is that we are iterating over the bars object that we created before with the ax.bar. And so for each bar, we get its height, and we use, which by the way the height is a coordinate within the plot, and we use x.annotate to, well, as the function implies, annotate the plot. The annotations of the plot is the 5.01 millimeters, 5.94 millimeters, and 6.59 millimeters that you can see on top of each bar of the plot. We create the text using an f string. We use the function round to round the height because by default it has several decimals after the point. So we round it to 2, and we add for millimeters. And what this actually means is that this is the average sepal length for the Setosa species, 5.01. 5.94 is the average sepal length for the versicolor species, and 6.59 is the average for the virginica one. So xy will be the position of these annotations that we are creating. They are coordinates. So the x coordinate will be the one for the bar that the annotation goes over it, which makes sense because the x coordinate is the bottom axis, and we calculate this by adding to this x coordinate the width of the coordinate divided by 2. This is so it is centered on top of the bar. And the y coordinate for the annotation will be the height of the bar. XY text parameter is just used to modify its relative position. Text coordinates are offset points, and HA and VA mean respectively horizontal alignment and vertical alignment. And to finish with this plot, we are going to create a legend. For this we need to create the labels. This is just a list with the name of each species, so Setosa, versicolor and Virginica, and we use the ax.legend function to create the legend. So as parameters we just have to pass the bars element, the legend labels we just created. We can give a title to the legend, the location, which in this case is, I chose to put it in the lower right part of the plot, the font size and the title font size, and frame on equal true. This is the frame that you see around. You can choose to put it or not put it. And just to finish this visualization, we can use legend.getFrame.setEdgeColorBlack to make this frame solid black. Now that we created the bar chart, I want to plot next to it a different chart. I want to create a sepal width versus sepal length point plot. So to do that, the first thing I'm going to do is I'm going to change this plt.subplots. I'm still going to have one figure, but I'm going to have two axes. Ax1 that we just, well, ax that we just created, and ax2. And plt.subplots will have arguments now. It will have only one row because I want it all to be in the same row. So the new chart, the new plot will be next to this one to the right. So only one row but two columns. And I add a figure size of 12 and 5. You can experiment with these figure sizes if you want. So for this second chart I create a grouped data frame called dfiris group. And to do that I just have to use the group by function from pandas. So I group by species. I define the dictionary called species colors, and for each different species of my data frame and my future plot I use colors 0, 1 and 2. So these colors is the ones we just defined earlier. So to remind you, this is a NumPy array with the RGBA colors for this green, this pink and this brown. And next we have to create our scatter plot. For this we loop over the group data frame that we just created before, and this loop will create separately, one after the other, the group of points for each categorical value for each category of the data frame. So in this case each category is each species, and it will assign a different color to each. This is why we do this for loop. It is so we can assign the specific color for each group. Then we set a title and we set the labels like we did before, so nothing new here. And we create a legend, also nothing special here. We use the type layout, which is always recommended to use when you are starting to do complex visualizations with more than one chart, and even when you only have one chart and it is a bit crowded, it is recommended to use. And we use the plt.show to show our image. Oh, and that's it. So as you can see, this is a very nice visualization with, in the left side, the average sepal length for each species in the iris dataset, and on the right, the sepal width versus sepal length in the iris dataset. Okay, and just to finish, as a bonus, I wanted to show you that Matplotlib is really a very powerful library that offers a lot of possibilities. I'm not going to be giving lots of details here, but we will be creating a 3D chart just because I think it's pretty cool to be able to do 3D charts, even if it's not always the most useful thing. So this code that you will find in the Medium article, by the way, is very similar to the one that we used to create this sepal width versus sepal length. But now we are going to do a 3D map, so we are going to add a dimension, and our third dimension, we use the Z letter for it, will be the petal length. That is also in our iris data frame. So we import Matplotlib from MPL toolkits to create these 3D visualizations. You can find the documentation for more information about it. It is important to put this projection equal 3D in our add subplot function. So here you see, since we're going to have an extra axis, we add the label for the Z axis. And also in our ax.scatter, now we have 3 instead of 2 mandatory parameters. So as I said earlier, we add the petal length. We actually use the line2D function to plot this, which by the way you can also use in 2D charts, and boom, this is what we got. Thank you very much for watching. I hope you liked this video and you found it useful. If there is any Python library you want me to talk about, please leave a comment in the video and I will look at it. If you like this content, do not hesitate to subscribe to my channel. It would help enormously. Leave a like and I hope to see you soon. Until next time.